This section 6.4 is really a review section. So looking again at inverse trig functions, we've done this before. So let's see, for example, we've looked at these already, right? What if you had to find, say, 1? The inverse sine of negative root 3 over 2. So the first thing I had to do was I had to remember the range of this guy. So remember, inverse sine is going to give me an angle on the right side of the circle. In other words, something in between negative half pi and positive half pi. So when I'm looking at this, I'm saying, tell me the angle on the right side of the circle that has a sine of negative root 3 over 2. So it would be this guy here. Now remember, I would not want to write the answer in this context as 5 pi over 3 because 5/3 is not in between negative a half and a half. Instead, I would write negative pi thirds because negative a third is in between negative a half and a half. What about a number 2? How about inverse cosine of negative root 2 over 2? So remember, the range of inverse cosine is 0 to pi. Or in other words, the top half of the circle. So now I'm looking at the top half of the circle and I'm saying, what angle has a cosine negative root 2 over 2? It would be 3 pi over 4. Now 3/4 is in between 0 and 1, so that is correct. One with inverse tangent. So how about inverse tangent of negative 1? So the range, remember, for inverse tangent was negative pi halves to pi halves, but not including the ends, since tangent has asymptotes at the ends. But again, I'm looking at the right side of the circle, so I'm saying, on the right side of the circle, which angle has a tangent of negative 1? So that would be negative pi fourths. Negative a fourth is in between negative a half and a half, so that looks good. Again, in this context, it would not be appropriate to write the answer as 7 pi fourths because that does not fall in this set. So those guys are strictly review problems. So what about something slightly different but still very easy? What about something like find the angle theta? So here's a number 1. So say I have a triangle here. There's my angle theta. I know the opposite side is 8, the hypotenuse is 16. So we've done something very similar to this before. So we would be saying, okay, let me set up the appropriate trig function. So sine would be 8 over 16, or 1/2. So here I'm saying sine of theta is 1/2. Or in other words, I could say theta is the inverse sine of a half. Theta is the angle that has a sine of a half. So that angle would be what? 30 degrees? Or pi 6. It doesn't matter unless the instructions specify. So here's a number 2, finding theta. So here's my right triangle. Let's do the adjacent is 5, the hypotenuse is 9. So same idea, what if I do say the cosine this time? That would be the adjacent, 5 over the hypotenuse, 9. So in this case, well, 5/9 is not a special value like a half is. So I could actually leave my answer in exact form, the inverse cosine of 5 over 9. Now for fun, I put this into a calculator. I entered inverse cosine of 5 over 9, there's a button for that, and I got approximately 56 degrees. So here's something we did before with one difference. So how about I want to find the tangent of the inverse sine of 4/5. So the problems that we did before, we actually had the same trig function inside and outside. One was an inverse, one was not. Those ones we just canceled out. We had to double check that the value we got out was in the correct range. This is a little different since I have a different trig function inside and outside here. Actually, I think these are even easier. So what I'm going to do first is I'm going to look at the inner function here. So I'm going to say, okay, so say theta is the angle that has, or theta is equal to the inverse sine of 4/5. In other words, theta is the angle that has a sine that is 4/5, or couldn't I say equivalently, the sine of the angle theta would be 4 over 5? So let me set up a triangle according to that fact. So if I put my angle theta here, in order for the sine to be 4/5, wouldn't the 4 be here and the 5 be here? Let me find the other side here. So x squared plus 16 is 25, just using the Pythagorean theorem, right? So x would be, well, let's do x squared, 9. So our x is going to be 3. So when I look back here, now I have to say, okay, looking at my triangle, what is the tangent? So the tangent would be the y over the x, right? It would be 4 over 3. Very easy. Should I do one more of those? So same idea. So number 2, find the value. Let's do cotangent of inverse cosine of 2/3. So I start out with the inner trig function here, and I say, okay, so theta is going to be the angle that has a cosine of 2/3. So if I rephrase that, that's equivalent to the cosine of the angle theta is 2/3. Here's my right triangle. Fill in according to this fact. So the cosine would be the adjacent over the hypotenuse. Now I need to find the y side. So let's see, 4 plus y squared is 9. So y would be root 5. Okay, now I'm looking for cotangent. Let's see, so cotangent is, well, the reciprocal of tangent. So it's x over y, 2 over root 5. So I would rationalize that guy. So 2 root 5 over 5. And there you have it. Okay, what else can we come up with? Maybe a example, how about a little word problem? A kite is observed from a distance of 20 feet. I'm going to say C figure. A little vague there. And what does a distance of 20 feet mean? So I'm thinking, in this case, let me see. So what I mean here is a distance of 20 feet from, say, directly below the kite. So let's say the kite is like up here. There's the kite. Here's the person. So that's my diagram. So let's say for part 1, express the height of the kite as a function of the angle of elevation. Okay, so remember the angle of elevation is from a horizontal. How far do I have to look up to see something in the sky? So there's the angle of elevation, theta. Let's call the height h. So I mean, look at the information I have. I have the opposite and the adjacent. So the trig function that comes to mind here is, well, a tangent. So let's see. The tangent of this angle theta would be h over 20. So that's a good start. Now I have to figure out exactly what I'm being asked for. So if I'm being asked for the height as a function of the angle, when they say the height as a function of the angle, that means that I need to solve for h. That means the height will then be a function of the angle. That's very easy. So wouldn't it be true then that h is just 20 tangent of theta? So I can even write this in functional notation. Like, see, isn't this h as a function of theta? See how I plug values of theta in here? So there's my height as a function of theta. Now I can do the opposite. I could say, for part 2, I could say express theta as a function of h. Okay, same idea. I still have this same trig function. Tan theta is h over 20, but this time I have to solve for theta. Well, to solve this for theta, wouldn't theta be the inverse tan of h over 20? And again, I can write that using functional notation. This is theta as a function of h, since h is the input or the independent variable. Look like so. So then I have these two expressions, or these two functions, that I could use to answer other questions. Like for part 3, let's say, what's the height if, oh, I don't know, let's start with, say, theta equals 60 degrees. So look, here's my function that gives me the height based on a value of theta. So all I would be doing is saying, well, the height when theta equals 60 degrees is 20 tangent of 60 degrees. Okay, Now I know the tangent of 60 degrees is square root of 3. Okay? So the height, when the angle theta is 60 degrees, is just 20 root 3. Now I guess I should put some units. I think this was in feet. I'm just going to try to squeeze one other part in here. So I was thinking, okay, well, what if they said theta was 18 degrees? Well, I would do the same thing. What is the height if theta is 18 degrees? So I'm still using this height function, except this time, let's see, so this would be h of 18 degrees would be 20 tangent of 18 degrees. So what I wanted to point out with this one is, well, actually here, since 18 degrees is not a special angle, I could actually leave the answer in exact form in terms of tangent. So should I show you one other thing? So how would I use this guy here, the theta function? So I guess for a part 4, what if I said, let's see, find the angle of elevation theta if h is say 20 feet. Okay, so now I'm going to use this guy. This is theta as a function of h. So theta would be inverse tan of what, 20 over 20? So inverse tan of 1. That's an easy one, 45 degrees. So should I do the same thing where I'll say, okay, this was find the theta if h is 20 feet, so I'll call that A. How about find the angle if h is 46 feet? So now I'm going to do theta evaluated at 46 is inverse tan of 46 over 20. So let me reduce the fraction. Let me see, divide by 2, 23 over 10. Okay, so that one, again, I don't know the value without a calculator, since this guy's not a special value of tangent like 1 was. So actually, I'd leave my answer in exact form like so. Then I could use a calculator to say, get an estimate if the worksheet requests that I do so. So how about one last thing from this section? How about graphing one of these inverse trig functions, like, say, inverse sine? We've talked a lot about these. Let's see what a graph might look like. Well, what I know is, well, I know inverse sine, well, it's the inverse of sine, right? So maybe I start with just drawing a graph of sine. So let me see, here's 0, 1, or well, here's 1, here's negative 1, there's pi, there's negative pi. So let me fill in my graph of sine. So 0, 0, pi halves 1, pi 0, negative pi halves negative 1, negative pi 0. There's my sine wave. So my first thought is, well, if my goal is to graph inverse sine, I'm going to be reversing the x and y coordinates, right? That's what inverse functions do. So if I look at this guy, let me start by saying, okay, let me see, 0, 0. If I reverse x and y, well, that still falls at 0, 0. What about this guy here at, say, pi halves 1? Well, now that's going to be at 1 pi halves. Call this pi halves. This one at pi 0 now will be at 0 pi. Okay, look what's happening here. Let me keep going. So this one, negative pi halves negative 1. So that guy is negative pi halves negative 1. So now that will be at negative 1 negative pi halves. Okay, this last one at negative pi 0 is going to be at 0 negative pi. So all I've done so far is I've just reversed the x's and y's. This is my first attempt. So I mean, this guy would keep on going, right? So that's a good start. The only thing is, well, remember, this guy is supposed to be a function. These were the inverse trig functions, right? So doesn't that mean it has to pass the vertical line test? So this is another way of seeing why we have to restrict the range of inverse sine. So remember we said, but I know the range of inverse sine is, what was that? It was negative pi halves to pi halves. So doesn't that mean that actually I'm only going to have a segment of this graph? The portion that's in between, well, here's positive pi halves, here's negative pi halves. So actually the portion of the graph I should actually have here, let me label this, should only be, let's see, here's negative 1 negative pi halves, here's 0, 0, here's 1 pi halves. So in reality, actually, this is the graph of the function inverse sine. It is just this segment that has the appropriate range.